Let me draw a picture of this conical cup to understand the situation better. So let's assume that this is the conical cup and water is being poured into this cup like this. So the water is being filled at a rate of 3 cubic centimeters per second, which means the volume of this water is changing. So we can write down dV by dt equals 3 cubic centimeter. Can write down this as centimeter cube over second. For every second, it changes at the rate of 3 centimeter cube. So this is the information, and we know that the height of the cup is 8 centimeter. So this is the height of the cup. We can mark it like this, 8 centimeter, and radius at the top is, this is the radius at the top is 4 centimeter, and we have to determine at what rate the water level rises when the water is 4 centimeter deep. So it's somewhere like halfway from the bottom of the cup to the conical cup. So this is halfway when the height is 4 centimeter. We have to determine at what rate the height is rising. So for that, we know that we have to find out this dH by dt is, we have to solve for dH by dt. Okay, so using the given information, let's try to create a equation. We know that the volume of the conical cup is given by the formula volume equal to 1 by 3 pi times r squared h. And we can differentiate this both sides with respect to time. But before we do that, we need to convert everything in terms of one variable. Since we have to determine dH by dt, it's better we convert this into height. So we should not have a radius, that is a r variable, in the equation. We should convert this into h variable. So how do we do that? So imagine that we have another triangle like this. We can form kind of similar triangles at this point of time when the radius is 4 centimeter. So I'm going to draw the triangle like this. We have two similar triangles. Uh, the radius is 4 here and the height is 8 centimeter, and radius at any point is r, and the height at any point is h. So this length is h and this radius is r. So this is a similar triangle, which means the sides are in the proportional, corresponding sides are in proportion. So I can write down the relation as 4, this radius divided by the height, is equal to the radius r divided by h. So this is a relation. We can solve for radius from this one. This in fact is 1 by 2. So therefore r equals half h. So now we got a relation for radius. We can plug this into this volume formula and convert everything in terms of height. So I'm going to do that. 1 by 3 pi times of r is 1 by 2. So I put 1 by 2 h squared times of h. Let's simplify this. So this is equal to 1 by 3 pi times of, we have to square this quantity. Square of half is 1 by 4, and square of h is h squared, and h squared times h, we already have 1 h, which is equal to h cube. So I can put this as h cube, and this can further be simplified as pi times of h cube we have in the numerator, and in the denominator we have 12. So this is basically the volume formula. We have converted this into only h. We copy this here, pi times of h cube by 12. Now let's differentiate both sides with respect to time. So this is dV by dt equals, note that pi by 12 is a constant, so we will not have to differentiate. We can apply the constant multiple rule and then differentiate only the h cube. So when you differentiate only the h cube, we get 3h square, that is a differentiation using the power rule, and then we have to differentiate the h alone with respect to time. When we do that, we get dH by dt. So this is basically sort of a chain rule we are applying. So we apply the chain rule to differentiate only the h cube using the power rule 3h squared, and then we have to differentiate h with respect to time. Now we have all the information to plug in into this equation and solve for dh by dt. Maybe we can also solve for dh by dt just right now. So I'm going to solve only for dh by dt, which means I keep this dh by dt on one of the side, and then after rewriting I bring this to the left side. So this is going to be dv by dt all over. This is we can simplify this. We have 4. So this is pi h squared by 4. So I'm going to divide by this quantity pi h squared. Let me erase this by 4. So now we can plug in the information that we have. We know this dv by dt, as well as we also know this h squared. So when we plug in, we know dv by dt is 3. So therefore we plug in 3 over here, divided by pi times of, we have the h, the corresponding h at that point of time is 4 centimeter. So we plug in h equal to 4 here. This is 4 squared by 4, which means we can cancel with 1 power. So it's just simply 4. So finally we get 3 in the numerator, and we have a 4 here. 4 times of pi is 4 pi. So this is the answer. So therefore we can say that the water level rises by this quantity, that is, it rises by 3 by 4 pi, since the height is in centimeter, over time is in seconds. So we put this in it, which means option A is correct.